Okie dokie, guys. Here we go. Here we go. Here we go. I am so excited. I just downloaded the first little mini me. It was only 2 minutes. But you know how long it took to download onto YouTube? Wait for it. Seriously, 10 seconds. Now, I know it was only 2.5 minutes. But really, if it was TouchCast, probably still be downloading. So I know you're going to miss my double chin, and I'm feeling it right now. Got to do something about that. But I think I'm seriously going to be going with Doceri and YouTube from now on because that's going to save time in my life. Okay, so we left off right here as I flip through it on page notes page 4, number 16, and the question is simulation blunders. What's wrong with the following simulation? And we left off at A. Now we're about to do B. So B here we say, assuming that the probability of newborns being a boy is 5%, we want to use a simulation of 9 babies who were born at a local hospital. We want to use 0 through 9 on our calculator, okay, fine, to determine how many babies in each are male. So the question is, are we using 0 through 9 with male, or are we going the probability of 5, the probability of boys being 50%, are we using 0 through 4? So here, this is the error. As I look at this error, they're saying that the probability of a boy is equal to the number 0. Well, first of all, is equal to 50%. And then, so we're going to use 0 through 9 to represent. We have Scrabble, and we have the Scrabble game. We have, okay, each player, a drawing of 7 tiles. We have 100 tiles. 42 are vowels, 56 are consonants, and 2 are blank tiles. Let me pull up my highlighter. Okay, so Kate wants to choose 7 tiles, and as she chooses 7 tiles, is surprised to discover that they're vowels. Okay, we can use a simulation to see the results. Okay, so first, we need to state the question of interest. So we want to know, what is the probability of selecting all 7 vowels? That is the question of interest. Next, how will we use the random digit table to imitate 1 repetition of the process? What variables would you measure? Okay, so first of all, we are talking about, we're going to let 01 to 42 represent vowels. And I'm going to pause this so I can write the rest of it down, and then you guys can, as opposed to having this time, you don't need me to be on here for, you don't need the air time like that. So I'm pausing. I'm trying to pause. Okay, so first of all, to represent our vowels, as you can see, I'm going to let the numbers 01 to 42 represent the vowels, because we said up here there's 42 vowels. Then I'm going to have the numbers 43 to 98 to represent the consonants, because as you can see right there, we have 56 consonants. And then the others, the 2 blanks, are numbers 99 and 00. And that's the 2 blanks. So here's 42 and 56 and 2, which gives us 100. Then repeats are okay, because that means we get the letter more than once. No omits, because we're using every 2-digit number that we have. We're going to stop at 7 tiles. And then we're going to use our random digit table. And I'm going to just say across with 2-digit numbers. Okay, to find out which ones we will be getting. Okay, because we want the probability of all 7 vowels. So all I've done so far is ask how you would use a random digit to find out the repetitions of the process and what variables would you be measuring. So basically right here, this is our plan. Now, for number 22, we're going to be doing this tomorrow on Thursday. I got to make sure that I have access to the Chromebooks because we're going to be going on the computer, and we are going to be going on the Let's Make a Deal site, and we're going to have it do the choosing the door to see what the prize is behind, or to see if we're going to get a goat. So we're going to read that problem tomorrow. But I do want you to do number 24, and we're going to do that together. And as I do number 24 together, then you're going to go and do your homework. So take a minute to read this, and then we'll come back together after you unpause it. Okay. So right here we see that fewer than half the young adults turn off the water while brushing their teeth. We had a group of statistics students that asked 60 students at their school. 27 of them said no. And then here's the dot plot down here that represents the information. Okay, now, so we want to explain why these results do not give convincing evidence. Okay, so first of all, let's state the obvious. The probability of, I'll fill that in a minute, is 27 over 60, which is 45%. So that is the probability of, okay, saying no and in this case, no is that they do not turn off the water while brushing their teeth. But somewhere in here, it says that we have, we took this from the population, so the true proportion of brushing their teeth is 50%. Now let's talk about the phrase true proportion. True proportion is the same as the population proportion. So these things are synonymous. It's the same. Okay, so when we have our samples, that's not a true proportion. That's just, okay, that's the proportion for your particular group. I think it cut off on me again, so just in case it did. If I said that 25% of the students at Awanda took AP classes, well, that means that that would be the entire population. Okay, and that would be the true proportion because the population would be Etowanda High School students. Now, when I go into different classrooms, you know how I'm always referring to my classroom and then Boykins and then Lofgren and then Armstrong. If we were to go into their classes, sample 1, well, let's face it, if I came into my SAMP class and said, taking an AP class, that would be 100% because everybody in here is taking AP stats. Then we go into Boykins. Okay, she has freshmen, so she might have 1, maybe 2 kids taking it because they might be able to take AP Spanish. Then we'll have, so we've got 100% in my classroom, maybe 1% in Boykins, if she's, if you got a really brilliant kid. Then you go to Armstrong, and then as you look at Armstrong, she's got a mixture. She's got mostly juniors all day. Her percentage would be maybe like 40%. And then you go to Lofgren again, who's an honors teacher, so she's going to have a higher percent. But the whole point behind that is that those percentages would not be considered true proportions. Those are sample proportions. Okay? Those are sample percentages. The true proportion is what I started off with, what a population proportion is. And I said for this case, it would be the students taking AP classes here at Etiwanda, it being, what percentage did I say? 25%. So when the question is asked, explain why the sample results does not give convincing evidence that fewer than half the students brush their teeth with the water off. The population proportion equals 50%. The sample proportion, I'm off screen, there I go. The sample proportion is equal to 45%. So just like I was saying a couple minutes ago, as I was talking about the different classrooms, going back here, this is one sample. That's just one sample. This is the entire population. So based on that one sample, we cannot make a conjecture or an assumption about the entire population. Not to mention here that one sample gives us 45%. Population is 50%. If I take another sample, who knows? That might be 50%. Take another sample, that might be 65%. Because another sample, I should say. One sample alone could not give us legitimate information about the population. So this is why the results do not give convincing evidence that fewer than half, et cetera, et cetera. Okay, now lastly, I want to do part B. So suppose instead that 18 students in the class samples had said no. Explain why this results would give wrong evidence that fewer than 50% of the school students brush their teeth with water off. Well, now we're looking at 18 people in the second sample. I'll just refer to this as sample 2. And as we look at sample 2, that's 18 over 60, and 18 over 60 is 30%. So that's one sample, 30%. It's not likely. So we have 30% is extremely unlikely when the idea of the entire population, the true proportion, is actually 50%. So now, as I wrap up this question, you guys have your homework to do. So as I look at the pink sheet, we are ready for problems 15, 17, 19, 23, and 25. So in other words, we're talking about section 2 from your calendar. So I'm going to take a minute and finish writing this down. Then after that, I'll see you guys tomorrow. We get to play with computers again. Okay, so as I center this, okay, not likely, far away from the true proportion of 50%. Okie dokie, guys. I'm going home. I did this at school. I'm going to send you guys a link right now. YouTube. I will see you guys. Have a great evening. No. Got to come up with something I can't take to Ruth's thing. Bye-bye.